So in this problem, we're going to use a little bit of our calculators, and we're going to use a little bit of the Newton's calculator to help us make an educated decision about what to guess with. So this function that we're graphing here, we're going to try to find the x-intercept of is ln of x plus 1 minus 1. And so if we take a quick peek at what this graph looks like, we can see it has two x-intercepts. One of them's at negative 0.741, and the other one's at 1.24. Now, what I want you to imagine here, though, is if we have a tangent line, that if we draw a tangent line, and with movie making magic, we now have one, we draw a tangent line to the curve. Remember, the tangent line, the x-intercept of the tangent line is going to become the new guess that we're going to use in Newton's method. So, for example, if I were to do a guess of whatever this x value is right here, 0.74, the x-intercept of that function is at 1.343. So we're going to use that as our new input to draw our next tangent line at 1.343. So it would come over here, 1.343, and then it's going to end up being the x-intercept there, and so on and so forth. So that would have worked out fine for finding that x-intercept. The challenge is I want to find this x-intercept. And if I pick anything on the right-hand side of our minimum, you can see our x-intercept is always going to be going to the right. It's always going to steer us towards this 1. So I need an x-intercept to the left. So how are we going to do that? Well, anything to the left. But the problem, notice the slope here and how steep my red graph is. If I were to try and use this value of negative 1.832, what's the issue? I have a vertical asymptote at negative 1. So anything that's going to steer me to a intercept that's somewhere after 1, for the x-intercept to be after negative 1, to more to the left, will give me undefined, and Newton's method is going to break. If you type that into the function, you're going to get a whole bunch of errors. So we need to be very strategic about our guess. As we're making our guess, we need to look here and say, okay, what is my x-intercept about? Well, you could even use technology to help you get the about. It's about negative 0.741. So I'm going to go over here and make that my guess. What did I just say? Negative 0.471. As long as I'm close. Nope, 741. I switched them. As long as I'm close, it's going to work. This is how we use technology to help us get answers. And so now we need to do our derivative. So what would the derivative be? Well, product rule. Derivative of x would be 1, leave the natural log alone, plus leave the x alone. Derivative of natural log is 1 over the stuff. We have our guess. Let's do, I don't know, 10 iterations. And now if I hit submit, we're going to see we actually zeroed in on our value, but we have way more decimal places of accuracy because we had a good guess. So I encourage you, play around with the guesses, see how far away you can get. But just keep in mind, if you get an error, it's because you shot to a value after negative 1. I'll do that demonstration for you. So this x value is negative 0.32. Okay, so if I do negative 0.32 and I hit submit, we're going to get a whole bunch of errors because all the calculations behind the scenes are saying, I don't know what's happening. And so that's why. And if you come look at the graph, you'll see, look, it's shot over here. Our point was past negative 1 where we had our vertical asymptote, which gives us nonsensical solutions. All right, hope that makes sense.